Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Essential Requirements for Edge to Cloud Service Architectures with Dr. Anna Scott. Anna, welcome to the show.
Hey, thank you. I was just going to say I'm really excited to be here. Thank you for giving me a chance to come in and talk with you about Edge to Cloud.
So, Anna, if no one's heard Anna speak before, which she has, this is her third time, guaranteed. We just talked about that. Dr. Scott is our Chief Edge Architect at Intel Public Sector, and incredible background in the industrial space, oil and gas, and other things. Anna is our go-to when it comes to edge architecture. So welcome again, Anna, to the show.
Thank you so much, Dan. It's really a pleasure.
So recently, you headed up an effort to write a white paper on edge to cloud service architectures, and tell the audience a little bit about the experience. It was like herding cats, right?
Yeah, it's really interesting. Like. Obviously, Edge to Cloud encompasses a whole lot, right? So and it's a beautiful match for Intel because it hits all of the high points of the technology that we care about right now. So you've got, artificial intelligence is critical. You have Edge as a major component. Obviously, you have cloud as a major component, but then your network connectivity is really, really important too. And so to really kind of tackle this paper and just how Intel is approaching edge to cloud architectures, we got folks from all of those different areas together with some pretty impressive expertise, and really wanted to talk through how do we just stop saying, here's a great edge architecture, with no discussion about how does that then connect back into the cloud and take advantage of that. And again, we have great cloud architectures as well. So this whole effort of how do you pull everybody together was a lot of fun. And also, what's super true is we all speak very different languages. We have different taxonomies. We say words and they mean something to one group and something totally different to another group. And so it's got some really interesting challenges. Plus, just to have the discussions to really kind of pull these architectures together, we've had to ask people to learn a whole lot of things, right? Because you can't talk about how you can really make a solid edge to cloud architecture without your cloud folks knowing more about the edge and the edge folks knowing more about the cloud.
To me, I thought that was the most interesting thing in being involved in the discussions. The OT guys and the IT guys, I'm IT, you're OT, we were not speaking the same at all, right? When I would say something, you were like, no, Darren, that doesn't make sense in the OT space. So I thought it was really interesting because you're right. We both learned a lot from each other in addressing these new architectures that are spanning everything.
Yeah, and then you throw in network, and their language doesn't match either of those either.
The network guys, I'm sorry. The network guys, they can sit on the side. Network. Come on, that's just plumbing, right?
Not for this.
It's just plumbing.
Yeah, not for this anymore.
No, not anymore.
So, well, yeah, and I know you know, Darren. I mean, one of the really cool things about this was what we really learned with these discussions, especially when you get out to the edge, the communications is just hypercritical. Like, you're not going to design your edge architecture without a really solid knowledge of what your comms are, because that's going to dictate how much compute you need to be local, how much you can really rely on the cloud, how often you can rely on the cloud. And since we're both in public sector, we've got the added complexity of having use cases that are really highly centered on still needing to keep the functionality when you've got DDIL conditions, right, or the delayed, disrupted, and intermittent communications. So it becomes really, really important. And that's where I have to say, I think so many of the interesting conversations and so many of the new key points that are relevant really came from is just comms is no longer something that you can say is going to be there, and that it's got the latencies that you need, and then it's got the bandwidth that you need. You really have to rethink these architectures and the cloud connectivity based on those
So
limitations.
I thought that's interesting. So the first major difference that we saw between a cloud architected service infrastructure and the edge was the comms part, right? I think there's this big,
Hmm.
huge assumption, and I know I made it. I don't do it anymore because you schooled me very well. Which is I'm not always connected, right? Because a lot of the tools out there assume connectivity, and if you're not connected, that means you're dead, and I'm not going to deal with you anymore, right? That's what it typically meant. But
Hmm.
that's not the case in Edge, right?
Yeah, definitely not. And it's also true. I mean, I brought up this public sector example because obviously for military applications, that's really true. But one of the things we were able to do with this group is bring in a lot of experts from other verticals. So, like Karen Perry really helped us with the healthcare side of the world, and turns out healthcare totally has to assume that you don't have good connectivity, because if they want to do patient edge cases where, like, one of the ones I know a little bit about, that Karen had shared with me is that if you want to work in somebody's home because, say, they've got long-term care, you know most people are not necessarily sophisticated users of technology, especially if they're have a very serious health condition. And so how do you really set something up where you can do continuous patient monitoring, do proper alarming and alerting, and do all the things that you need to do when, hey, that person's internet or their Wi-Fi could go out? So how do you design around
Well,
that?
yeah, now you're dealing with
And
people's lives,
it's
right? It,
super
yeah, it's not like,
important
oh, I
stuff,
couldn't
right?
stream my Netflix
um,
video for 30 minutes. Now you're dealing with,
for a few minutes.
this is, yeah.
Yeah. And then it turns out industrial has really similar requirements as well. You can't be offline, because the control for certain machinery or for certain processes is just way too critical. And so this whole idea of how do you have this very edge-centric compute that maintains all critical functionality, but then can have connectivity back into the cloud and do that in essentially an intermittent fashion, right? So we can absolutely architect for that, but that's something that there's obviously been work from the edge perspective, but there's still a lot more that can be done, especially if you want a nice seamless set of operation of, hey, you do have cloud connectivity, now here's what you can do. Hey, you lost that,
Here's
here's
what you
what you
can do,
keep
yeah.
doing. Now, what does it mean when everything is restored, and what's your version of the truth, right? Because you're going to have a disconnect between what's been happening with your data. And in some cases, that can be very, very, very important. And then where it got really cool, right, when we were talking through this is, when you really do this at scale and you've got hundreds or thousands of edge devices, that whole idea of how do you synchronize all of that data, if you're trying to really understand what's happening across a large area and across a large time frame, you get into some complexity that is really
Yeah, yeah.
fascinating,
In
I would
fact,
say.
one of the more
Yeah.
interesting ones is, let's say your cloud goes down, you have 1,000 nodes connected, and then you reconnect.
Mhm.
You can get a comms swarm where everything's trying to communicate all
Absolutely.
at once and send all the data they had all at once, and you'll overwhelm your cloud instances. So,
Yeah, and I wanted to highlight, like, we didn't really do this in the white paper. When we wrote that up, we tried to keep it uh, focused on, here are the things that matter, as opposed to, here's the technology that we have that can help address these problems, right? With the idea that what we wanted to do is start the dialogue and help provide a framework for how to think about things and where to look for some of the disconnects that we've identified. But, like, if you're up for it, Darren, I think talking about the work that you've done with Edgemere is really fascinating, right? Because Edgemere is really designed in a way that allows everything to work well, even when you've got that sort of a complex situation where tons of edge nodes, you've just come back onto the cloud. How do you make sure your comms are, how do you make sure that your system isn't overwhelmed because everybody's talking at
yeah,
once?
well, and I have a couple podcasts on Edge Mirror. I'll point people to them, and
Perfect.
But Edgemere is this, like you mentioned, it's a conceptual architecture on how clouds work, cloud to edge work, and the things you have to watch out for. But I want to go back to kind of these requirements that were flushed out, right?
Okay.
Because we talked about
Perfect.
comms, which is probably the biggest one. Let's talk about some of the other ones like security, right? What's different in security on the edge than like in the cloud? What's, would you say, the number one thing?
Probably the number one thing is your edge devices could be picked up and carried off.
Yeah,
right?
someone could steal it.
So physical security is a different thing at the edge, and depending on how critical your functionality is and what's actually on that edge device, there could very easily be information that you don't want to be retrievable. You also want to make sure that if somebody takes an edge device, that doesn't give them essentially an entry point into your network. So there's a whole new set of requirements that that really come to place. A lot of the traditional security stuff is still super important, right? You still want to do all of your authentication. You still want to be able to know that the device is the device that you think it is. But we have to step.
Yeah, I thought it was interesting when we went over the security ones. There's new cases where I can put an edge device out there and proxy or spoof your cloud instance and say, hey, I'm one of your edge devices, and all of a sudden I'm sucking down all the information, all of your critical information, or I'm just feeding it garbage, which could, cause major problems.
Be just
Yeah.
as
So
bad.
security on the edge, it's a little scary to me, frankly.
Yeah, and I would say it's also where we need to, like, we as an industry need to be devoting some more time, right? Because there are very good solutions that are out there, but it is just a more complex world. And as we talk zero trust architectures, which again for public sector is super important, edge devices are just this huge attack surface now, right? And in some ways, it's not so different from, hey, everybody's working on a laptop from home,
That's
and who
an
knows what's
interesting
happening with your
point. Yeah,
network,
COVID kind of pushed us a
right?
little bit to secure or come up with better edge security solutions.
Yeah, and there's a lot there, but one of the things that we realize that we really want to be working on is we have great laptop security and we have all sorts of ways to protect around that. Those types of capabilities aren't necessarily applied to edge devices that are not laptops, that are for more industrial functionality or are being used say for a machine vision or a computer vision type of application. And so there's a pretty solid dividing line, and we really do at Intel want to work this idea of how much of what we've learned with our PC security can we extract and really start applying into what used to be called gateways, but nobody likes to say
Because it's an old
anymore.
term, right?
It's it's your edge device, right? And say, what can we leverage there, and are there some rapid iterations that we can do that that help? And often there's a big divide on operating systems, right, between those two, because Linux is still the winner when you're doing anything with a more functional and more more application focused, as opposed to like a traditional type of workloads that you do with PCs. So so it's a fascinating world. I wanted to mention one thing before we move on. The other thing that is new that hasn't we haven't really seen adopted or used yet, but is absolutely within line of vision, is this idea that for your edge devices, we now know enough about what the edge device is supposed to do, where it's supposed to be, how to confirm that it's in the place that it's supposed to be. There are some new things that can really be brought into security to say, don't just stop at, hey, I recognize this ID, right? Or I recognize the device. Can we confirm that with the other edge information that we're collecting as a result of the application, that
In the right location?
Is its primary function, right? And being able to do that gives us a whole new horizon of just what we can really monitor and what we can flag as anomalous behavior. And that's where AI from application standpoint is beautiful, but if you just say, let's start talking about how you can use AI for anomaly detection to say one of my 10,000 devices is really out there with respect to what we would anticipate given how what its design functionality is, right? So there's some really, I think, amazing stuff that's going to be coming in the near future um, because we just have some really good
All right, let's talk a little bit
capabilities
about
out there. So
application because you mentioned a little bit I can use AI to help anomaly detection. Whether an application is running appropriately on an edge device or the edge device is doing what it's supposed to, how are applications different in edge than they are in the cloud?
yeah, so obviously there's a strong push to have this be containerized, right? Because one of the things that you really want is you want portability of those applications, and so you, without having to say, I know exactly what this piece of hardware is, and I know its operating system, and I know everything about it. You don't want a custom design in that. You want to say, hey, that architecture is set up for a container, and now I'm going to just plop this new
That's a
capability
major
down into
shift,
that.
right? Because in the past, edge, it's all
Mainly
custom stuff,
custom,
right?
yeah. Yeah, yeah, and there's obviously been use of containers and use of virtual machines, but when you really want to scale this, and especially like the thing we spend a lot of time exploring, right, is where it becomes the most relevant is uh, we're still going to develop most of our applications on the cloud or in a developer environment, right? And so where they're all going to be tested and used is going to be there first. But if we can have a good understanding of what those applications really need to run at the edge, and again, do that in a compute limitations, with power limitations, with connectivity limitations, right? And say understand those up front so that when those applications are developed, there's actually a very clear way for, hey, here's how you can drop this down into this new location without having to take an additional step to be able to reprogram, you without having to bring in new middleware because, hey, you've got this great application, but to be able to understand your data, you still have to do a whole nother set of software development so that it can get its raw data feeds so the application has something to work on. So again, lots of things have been done in that space, but again, just this whole idea of begin with the end in mind, appreciate that the edge environment is very different, and before you start building those applications, take advantage of the fact that you know what your limitations are on the edge. We haven't talked about this yet, but let's do a quick diversion and say, let's talk about how diverse the edge can be, how much it can be a new distributed compute setup, because where we also see some really remarkable things, right, is um, most designs right now is you have a single piece of compute, or maybe like a few small servers, and you can run your applications right there. We are already able to say, can you design that application so that it could actually run off of a mesh network with highly distributed compute, where now that is just, if you've got 10 nodes out there and all 10 nodes of those are in place, now spread
Across
that
it.
heavy
So
application across
that
all of
lends
those,
itself really well
right?
then to containerization and decoupling the
Mm-hmm.
application from the hardware. And that's a major shift, right?
Yes. Well, yeah, and uh, well, and then just getting more
Right.
generic and less
Okay.
purpose built, right? IoT and edge is be still very much like, here is the single application that you're going after. Here's your data feeds. Here's you know, and here is your one set of code that's going to use those data feeds to give you one answer, right? And that is great for situations where
Yeah, well,
you only
which
want to do
doesn't
one
happen
thing, right?
anymore, right? I mean,
Um,
those development cycles are years long, and now we need to get into developing new applications in
yeah,
months instead of years.
yeah, and they're constrained and they tend to be very proprietary. And you have one company that can actually keep them going. And so this whole idea of like changing the whole dialogue to say, hey, now what we really want is we want data from anywhere we can get it, and then we want to plop down whatever.
No,
Why
that's
am
a
I
good
saying
word.
plop today? That's just somehow working for me. We want to use whatever application whatever application is the cutting edge application that we care about, right? So we want the software part of that to stay extremely current and robust and be able to take advantage of all of the advances that are being made, and then just really marry up very quickly and effectively to the data that's available. And then if we can make that even more robust by saying you can use whatever compute you have at the edge, and if your application is too big to run on a very constrained piece of hardware that you've got, if there's others in the area and you can mesh that out, now you can really still support that application at the edge.
So you mentioned something which is the next major requirement. It's data management.
Yes.
Right. This is a major shift. Right. This is probably right up there with comms. How do I manage data on the edge? I remember when I first saw edge architectures, everyone said, "Oh, 5G is going to fix this." Because I'll just connect.
Right. Exactly.
5G will connect it all up, and there's more bandwidth in 5G than I could ever fill. And that's completely shot to smithereens. I mean,
so it still can work, right? It's just, it depends on, one, do you actually have that network available, and then can your applications have that be, are your applications such that you can support it with a centralized model where maybe your data is collected at a local, at an edge location, but then everything happens in the cloud. And then do you want to pay for it? Right?
Yeah. It's the volume of data too. There's so much data being collected at the edge or generated at the edge.
Absolutely.
I don't think I want to send all that raw data to a data center to be processed.
Yeah.
I just don't.
Yeah, and in most places the cost is too high. I mean, that's one of the nice things. I will give a bit of a plug for private 5G. Part of the reason that private 5G, and again, this is very US centric because the spectrum allocations and things are different in other parts of the world, but for the US, like when they opened up CBRS spectrum and allowed essentially the individual users or private users to take advantage of that spectrum, so that now, instead of always being beholden to a carrier, you could stand up your own 5G network on that available spectrum. And now you care a whole lot less about those data costs because what you're already paying for is your infrastructure and keeping your network going, as opposed to doing a normal cost structure if you're working with a carrier. So there are some things that can happen that can make it very cost effective to still just move a ton of data over your network. Obviously, you can do some stuff with Wi-Fi 6 too, but again, like most people and for most organizations, you're not standing up a private 5G network or 4G LTE network to do your work, which means you got massive data rates and high data rates that you have to pay. So there's a good incentive to get your.
Well, you also have to store all that. I had to store all that data.
Right?
Right. I mean, we're talking exabytes of data, not petabytes. Exabytes of data being generated. A 4K camera is outrageous, right?
Well, and most of the data is of no use, right? Because luckily, when we're trying to monitor something or we're trying to understand something, as a rule, most of the data that's coming across is telling you that everything's okay. And all you really care about is when things aren't okay, right? And that's where the value of the computer vision and the edge capabilities and really applying AI algorithms gets really exciting because you can do that and do that very effectively. But if we go back to data management a little bit, Darren, you're really much more the data management expert than I am. I did hope that we could talk a little bit about some of the work that Stan Moe has done with SADE.
With SADE,
right, and how that kind of makes sense and works with the edge mirror architecture that you also have. But maybe as opposed to talking architectures, we can say, here's the cool stuff that those types of software do to help with a problem, right?
Yeah, you turned it around. Now you're interviewing me. Way to go, Anna.
Yay.
No, that's good. No, you know what? What we found was there's different modes of operation for data management, or we call data ops. The traditional one is copy everything to the data center and run analytics there. Mm-hmm. And everyone's been doing that for decades. And they're finding, that doesn't quite work for edge, so we're just going to push applications out to the edge. And that doesn't always work. So we've identified a couple other data architectures or data ops. One is called a data exchange, where it's a combination of moving data in
Hmm.
secure enclaves or only after it's been analyzed on the edge, and that's in like batch type processing. Another a fourth one is what we call intelligent data streams, and this is where Sadie and Sabre really come into play, where I'm only moving data based off of rules, and it's being streamed, and it works in these DDoS environments that you talked about. So
Hmm.
it's not just, hey, this application always does analytics and sends it. It's what's the current operating environment? Is it a full bandwidth? I'm going to send everything I possibly can, or am I only getting kilobit right now?
Hmm.
Or do I have no comms? I need to cache and do some massaging of the data, and then only send what really matters later when I reconnect. So there's lots of really cool things around the data management side. We should probably have Stan come on the
We
show
should.
and
Hmm.
talk about it, because we can go for another hour or two just talking about data. So, all right, we're
Agreed.
going to move though because
Yep.
we'll
Yeah.
never
Yep.
finish. Let's talk about manageability. And what does manageability really mean? Well, you kind of touched on it a little bit earlier, but give me why this is such a requirement.
Yeah. So this is the classic edge problem for industrial, but also for for other verticals, which is the real promise of IoT has always been this whole idea of there's billions and billions of devices, and now you've just got this massive amount of data. But there's the very real problem that's like, hey, let's just talk 100 devices, and how are those 100 devices really going to be monitored, updated, authenticated? How are you going to make sure that you're pushing your updates and the updates are actually loading and that everything's healthy and you're responding as expected? And then that whole set of problems is something that everybody's known about it for a long time, and in some ways isn't terribly different from, hey, your entire workforce just had to stay home for for has to stay home for two
Yeah,
years, and now you've got a 10,000 person organization, and hey, how is that working, right? I mean, so same sort of problems, but now you just don't have a person at the other end that can pay attention to the updates and can do the what's our term for the Wednesday
the
updates,
Wednesday
right?
reboots.
Yeah. So, but that all still has to happen, right? And especially if you've got network connectivity, you can't, like the current industrial thing, right? Is like you may have some connectivity, but essentially you'll put something in the field that has a dedicated capability, and you'll leave it there for 10 years, and
And
maybe
don't touch it.
you just don't touch it, and maybe you do the firmware once every 10 years, and then you do it by sending a guy with thumb drive, right? um, in modern systems, especially when you want to do them at scale, and especially when you want to get it, get a lot more devices out there, none of that stuff makes any sense. And so you need to really, well, these systems just absolutely have to be architected in a way that they can be maintained, because you can't say deploy 1,000 devices to a remote location, and then have a small army of people that are going to be going there on a regular basis to make sure that everything's working. There's no economics in that. So to
But
build the
it
system to
doesn't.
be
Isn't that?
manageable.
Yeah, isn't that kind of? I know the IT guys are very cautious around this
Hmm.
space
Yeah.
because and they don't upgrade things because don't touch what's working mentality. But there's a lot
True.
of fear around ransomware attacks on OT networks now. And
Absolutely. And that's why you can't leave it alone, right? It's like
gotcha.
there's almost nothing worse than you can do to say, hey, we're not going to fix it because it's not broken. But that's not true from a security vulnerability perspective, right? So if you're going to have this type of connectivity, you have to have a way of keeping everything updated so that it's got the robustness that you need to deal with with the environment that we live in with respect to security. So yeah, and there's a lot of different points. I mean, this is again like all of the things that go into edge of cloud are fields on their own with experts and well developed industries, and lots of time spent. It's so we did the very high level thing, which is just don't neglect this, because don't just go out there and start throwing out some good architectures, because if that architecture hasn't been crafted to be with manageability in mind, you're probably going to find that your management's going to say thank you, but go away, because we're not ever going to apply it. Right?
Yeah, no, I
So,
agree. All right, there's one major one left, and that's availability, which we've already kind of touched on a little bit.
yeah.
Availability. Anytime I think of availability, I remember when I was a CIO, and we talk about availability as in 3 or 4 nines. My data center's up 4 nines. Yay!
Yeah.
But
Yeah,
for
exactly.
edge, you don't talk even double nines, do you? As far as availability
Uh,
goes?
so we would love to, right? The way that it works is if we need that type of availability, it's still all hardwired, and then typically has the redundancy built in. So that's one of the things. Like if we go back to the healthcare model, this is where that part of it becomes really critical,
Oh,
right?
I don't even
Because
want double nines. I want 100% uptime
you
on
want,
my.
yeah, like 9 nines or like 7 nines, right?
Yeah,
Which
exactly.
is almost impossible to meet. But it does become like a whole new world of saying, okay, it's not, again, good enough to have an edge architecture, or have a manageable edge architecture, or even have an edge architecture that can communicate with the cloud and take advantage of that with these nice seamless applications flowing back and forth. It is, can you design that with sufficient redundancy based on what the applications need,
Yeah,
right?
I like that approach because it's
So
more of a systems approach. I don't care if one component fails. As long
exactly,
as the
right,
mission, see, you can tell I've been in the DoD way too long. Everything's a
right.
mission. As long as the application, like on a hospital bed, right? As long as I keep that patient alive and notify if there's issues, I don't care if individual components fail, as long as I meet the end goal. And
Right.
that's very, very different than what we do in the cloud. It's all about keeping the infrastructure up.
Yeah, and like I'll see if I can give an example, because I think at edge it's harder, because there's also a cost sensitivity at the edge, because you want to get the scale where you've got, lots and lots of devices and lots of capabilities, right? And so one of the other things that Intel does is we have a smart edge platform. I've worked the most with the commercial, so I'll talk about that since I just understand it better. But like one of the examples is like for some applications, you could say, here's a Smart Edge MEC application that has really good network connectivity. You can use 4G, 5G, LTE, Wi-Fi 6, whatever is available, and it can work. Has a Xeon class server, and it will work with like, say, 10 to 100 different edge devices, right? And that could be a really solid architecture, but that almost undoubtedly does not have a high enough availability if it's single server and if it's single network, right? So if we're really talking availability, there is extra cost that you have to throw in, because at a minimum you need redundancy of compute, but then you need that software to be designed so that if
So we
there is
can
a
handle it.
fail,
Yeah.
if something fails, you have a seamless set of operation, right? Ideally, and this we're not there yet, but is on the radar, is this idea of, hey, if you can get your hands on multiple networks, then you don't want a system that's designed for a single network. You really, and this is especially true in the in the public sector side of the world, you want a system that can say, hey, I've got Wi-Fi 6 and I use that preferentially, but if I lose my Wi-Fi, do I have any 4G here, and can I keep the network moving so that I still have good connectivity and I can still do what I need to do? So it's almost like the availability is a bit too twofold, with respect to making sure your compute is solid, and then making sure that your network connection is solid. And again, we can design to be standalone operations without the network side, but then does that mean you're hardwired to all of your devices from your
That
MEC
means it's
server?
fragile, right? It's
Right. And if you go hardwired, costs get higher. It's limitations. You lose your mobile applications, and so this whole idea of how do you get your local network to be
highly
highly
available.
available as well, and often what that means is you've got to just go redundant, right? So yeah, it's fascinating
So
stuff,
yeah,
right?
that's
And
interesting because you tied cost. Cost of course is something in there, and it's almost in opposition to availability and things like that.
mhm.
So Anna, this has been very insightful. If people want to find out more you guys can go to embracingdigital.org. There is a white paper there. You can also find the white paper on intel.com. The white paper is called Essential Requirements for Edge to Cloud Service Architectures. Go out and look for it. Dr. Anna Scott, thank you again. As always, it's a pleasure.
Hey, thank you, Darren. It's a great conversation. I appreciate it.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.